Okay, gang, this is W1REX, Rex Harper, and we are going to, well, not we, I'm going to show you the build of a Tuna Tin 2 40th anniversary kit. One thing what I want to do is, there's not very much documentation because it's a fairly simple kit, but once you know the basics on how to build it, it should be fairly simple without any step-by-step. I have two documents here. Here's this schematic. You notice the power comes in and goes down. You got a keyed 12 volts. All the items have designators. See, here's a here's a C2.1 microfarad. Comes down to the oscillator, which then goes over to the final, which then goes to the low pass filter, which goes to the outputs. If you look at the circuit board, it goes the same way. Here's the power comes in and comes down to the key, and then goes over. Then you have the oscillator. Every part on the schematic is exactly in the same position on the circuit board, so it's pretty easy to translate from one to the other. And the whole thing is laid out exactly the way the schematic is laid out, so it makes it pretty easy. Also on the board, it's pretty hard to see, but if you've got one in your hand, you'll see there's no, over here it says C12.1 microfarads, or over here it doesn't say C12, it just says 0.1 microfarad. So this, rather than clutter it up with everything, I, on this board, put the part value instead of the actual designator. So you can pick this board up. If I didn't have the schematic, I could pick this board and say, oh, okay, 0.1, 47K, 4.7K. I can build this board without any information at all because all the parts and stuff are on the board. One place, no, I don't think there's anything in particular other than this tip and ring business over here, which is a little bit confusing. And that's because you have a stereo jack coming in. Typical keys or paddles have an 1/8 inch stereo jack, and the very tip of the plug is the tip, then there's a ring, and then there's the ground part. So here's what looks like a plug, and the very tip of it is called the tip, and the middle part, which is isolated, is called the ring, and then the final part, that's the ground. And it's just the way that tip and ring comes from the old telephone switchboard plug-in things back when they had, operator, could you give me an extension? They would take a patch cord and plug it into that person's phone line. That's where tip and ring come from. Anyway, so we can build this kit without really, I'm not going to put this white background here because it really blooms the camera. But we don't really need the schematic or the parts material list other than to identify that you've got all the parts in the kit. So the first thing we're going to do is I'm going to take a clipboard here. I got a clipboard with a piece of graph paper, and I'm going to take the parts out and I'm going to separate them. I'm looking now at the bill of materials, and what I'm going to do is I'm going to separate things which are obvious. Okay, so I'll pull that out. That's obviously a nut and a bolt. Here's some RCA jacks. There's two whites and a red. Here's a stereo 1/8 inch stereo jack. Here's a crystal. Here's a switch. So here's a diode. Here's a green thing. Here's a brown thing that looks sort of like a resistor, but they're bigger than resistors, and they have a weird, almost looks like a wasp. They have a waist. Whoops, I'm off camera. Sorry about that. Okay. They have a waist to them where they sort of like the body of a wasp. So those typically are chokes, axial chokes. So I'm going to pull those out and set them aside. Here's a transistor right here. Here's two transistors. Here's a 3-pin SIP socket. Here's some capacitors. I'll put the resistors up here. Again, I'm just sort of separating them out into like things alike. And there's another resistor that's already preformed, some capacitors. So lots of them connected together. So I've now separated all the parts out. And you can take a, whoops, another capacitor, lose its value. There's another capacitor, a couple of, okay. So here are all the parts all separated. Now I can see that I have, let's see, 1, 2, 3, 4, 5, 6, 7 resistors. And I'll look up here on the, I'm looking at the bill of materials, and I see for resistors, I see 1, 2, 3, 4, 5, 6, 7 resistors. Then I see 1, 2, 3, 4 chokes. 1, 2, 3, 4 chokes, and this is a diode, obviously. So there's a diode up there. So I got one diode. I got a 22 microfarad capacitor. That's that. So I've now gone through the top of the list, and I've got everything there. I got 1, 2, 3, 4, 5, 6.1 microfarad. There's 6 of them right there, I'm pretty sure. That should read a 104. These are very hard to read sometimes. Sometimes it's best to have a handy dandy. If you don't have a, I'm at my video station, I don't have a big magnifier on this thing because it's the camera takes up all that kind of room, but I got a little handy dandy little magnifier that I can just, 104. Okay, so there's 104s. There's 6 of those. So I can go ahead and mark those with my pen. 1.1.1. Okay, so I'm just going to align these up. I'm going to put the big ones down to the end because that typically signifies a bigger capacitor. Okay, so I'll put that down there. So now I can just take a look at that one. I can see that's 220, 220. So these are both 220s. This is picofarad. And this one right here is 680. I'm going to put that on the other side of it. 680. Whoops. Double check that. Yeah, 681. 680 picofarad. So what do we got here? That's a... No, that says K1J. You have to flip that over because that's K1J is temperature and other things. So that says I'm going to put it up closer to the light that I have up here. This is probably the most 391. So that's the 390 picofarad. This one here also was on the wrong side because on one side it says K3J, which tells you its temperature and stability. And on the other side, when you flip it over, it says 560. So that's 56. 5, 6 with 0 zeros. And this one here is again, it's got the temperature spec on one side, and over here it says 121. So this is 120. And so over here, the last one, K2J, it says 101. So that's a 100. So I can go look at these capacitors. I see a 100, I see a 220, I see a 390, I see a 120, yes, I see a 680, yes, I see a 56, yes, I see a 220, yes, I got 2. So, and I see 2 transistors, yes, are they both PN 2222s? They should be. I mean, when I kit these, it's pretty hard unless one jumps into the wrong bin. 2222. Okay, so we got the transistors. So now we got down to the. You should be able to have your resistor codes down pat. There's a brown black, so that's a 1K. Brown black red. Let's see what this one here is. yellow, violet, orange, so that's 47K. I happen to know that's the highest one in the kit, so we'll put it on the other end. Let's see what this one here is a yellow, violet, red, so that's 4.7K. We'll put that in the middle somewhere. And what do we got here? Gray, red, red, that's 8.2K. Let's pick this one up here. And there's a red, red, brown, so it's 220 ohms. This one here is a, excuse me, that's a green, blue, black, so that's 56. And then we had the one that was already folded over, bent over. Now, this is a 1% resistor, and they read a little bit differently. Brown, black, black, black looks to me like, and I'm looking on the list here, brown, black, black, black. I think that's 100 ohms. I'll put that up in this corner. Now, you should have your meter, your voltometer floating around somewhere. I can very quickly test that one. And, yep, 100.2 ohms. So I can verify that I have pretty much everything. Now I'm going to put all these parts off to my bench left. I'm right-handed, so my tools and stuff are going to go on the right-hand side of me. So over here on the right-hand side, I'm going to put the schematic up top side. Here's the board. Throw the bag away. So just to show you, here's my collection of tools. I got a iron tip cleaner, which is the brass shavings. I have some solder. I'm going to move that off my thing because I'm going to use that close by. Magnifier. I got a rubber band. I got a lead former, which I use a lot. I got a nice double-ended Gifties. This came from a company I know, and one of those gifts that they give away. Flush cutters, flat on one side, chisel down to that. You can get right down to the board and snip the lead off without any stubble. I do have a cheesy little utility knife. I got it Harbor Freight for 25 cents or 50 cents. And my favorite pliers. And these are really nice. Nice, fairly straight, squared jaw, not rounded. Nice serrations. I just love these pliers. I've been using them for years and years and years, and I have many pairs of them floating around. The rubber band, often when I'm doing something that I need a third hand, when I'm not, there's my third hand. I can basically, let's say I wanted to, let's see, just trying to, just as a for instance, I mean, if I want to tin, if I was going to cut that thing off and tin it or what have you, there's my third hand right there. I mean, it's just you sort of be creative about trying to use multiple things in multiple ways, or a minimal amount of things in multiple ways. So that's just one way of dealing with it. Now I'm going to put all these tools off to the right hand on the bench. The other thing I have is I can show you building this thing. Whoops, I forgot to plug my iron in. Into the plug strip. That helps. I turned the iron on, but I forgot to plug it in. I gotta go onto the back of the table, find my plug strip, plug it in. Now, in my house, I have house and shop. I have about, oh geez, I got 5 or 6 different places where I work, and I've got soldering stations just about everywhere. And, you know, a good station is 50, 60, 70, 80, 100. I've got some of those. I've got one that costs, it's a real production unit that costs about $800. I didn't pay that, being the cheap QRPe that I am. But that is a truly professional iron that has an RF coupling to it. So what it does is it stays hot. It provides a lot of heat, but the unit is built like a brick. I mean, the base on it is about 10 or 15 pounds. So that stays pretty much on one bench. But this iron right here I got at Amazon, I think for $18, $17.97. And this would be the typical iron I would recommend for someone just starting. You can see it has a digital temperature here. It's set at 456. I can do a plus minus. So let's bring that down to, this is degrees centigrade. So let's call it 450 degrees centigrade. Oops, I'm going up. Doesn't make any difference. Okay, I like to run my iron hot. So when I solder, I get in there, I quickly get the solder on and get out. So you can see this tip. The nice thing about this is it is a changeable tip. So you can screw this thing off when it's cold, of course, and you can change the tip based on your work. Tip cleaner. When I start a project, you can see that was kind of cruddy from when it cooled down the last time. Now I have some backup stuff. I have this tip cleaner goop, pretty stinky. I think they call it sal ammoniac, I think is the actual chemical name of it. And the idea is I can recondition the tip a little bit. So you see I went there, and now I've got a pretty nice little tip right there. Good load of solder tin on it. So that thing is pretty much ready to solder, I think. We'll find out. It didn't take very long to heat up. Let's see what we got here. Oh yeah, she's quite hot. So I'm going to set that off on bench right, and make sure I got enough lead to be able to get in there. Okay. All right. So I'm ready to build this thing. So how do you decide where to start? Well, in my case, I always start with things that are low to the board, things that lay down on the board and are nice and totally out of the way when you're working. In this case, I'm going to start with the resistors. So I'm going to just, plunk one off. Now, you can either, here's the thing, you can take and get a resistor and then search for where it is, or you can find a resistor on the board and say, okay, I'm going to put this first one in here, 47K. Well, we've already written them down over there on the just bringing this just for an example, because over here in the resistors, I've already written down 40. I've sorted it out, and there it is, so I can just plunk it right up. So the easiest thing to do, fastest to build a kit, would be to find a part, or to decide which part you put in, and then just go get it. In this case, I'm going to start with this 47K. I've got a lead bender, so I can put that in there. All the resistors are bent at, or formed at 0.4 inches, so I can bend that at 0.4. I can put that in there and put my finger on it, flip it over, and bend the leads apart just a little bit so it doesn't fall out, and there it is. Now I could solder that, clip them off, and move on, or I could put another one down. Doesn't make any difference. In this case, it's nice to be able to have at the start, because things are relatively flat, this board is not very wiggly. So I would, two things. I would either put a couple of resistors at different areas of the board so when you lay it down it's nice and flat, or I would get some sort of a board holding mechanism to hold it off the bench at some level, and I do have those in my product line. But because this is a tuna can kit, you also have tuna cans, so you can just take this board and pop it right in there, and it's perfectly level. But that only works until you start getting parts that stick out beyond the board. Then you've got a problem. But we'll just start from here. So I'm going to take my I'm going to take my solder and I'm going to cut off about a 1 foot length and just do a little curl up so it's nice and handy. And again, I'm going to move my tip cleaner because I'm going to clean my tip often. You want to have clean solder, clean board, clean iron. And I just leave a little dollop on there so that when I put it on the lead and the pad, heat will flow to all 3 pieces, and I move in there with just a little bit of solder, and that's it. That's all it takes. It's not a big deal. And see, I can swing this thing around, and I'm going to get right in here. I'm going to make sure I got a little dollop there, so when I put it, I'm going to try to leave that dollop and have it on the pad and the lead at the same time. That helps flow the heat. And then after a second, come in there with just a little bit of solder, and there it is. So I can now take this flush cutter, and I'm going to take and put my fingertip on the lead, and then I'm going to go down and cut it right off right at the base, and you'll see that this thing didn't go flying. And one of the things you can do is have another tuna can floating around. You can put those in so that you don't create a mess. You don't want them flying, you know. This is a nice shag carpet, short shag carpet up in this room, so I don't want those ending up in the carpet. And there you go, there's your first part. Now the thing is, you can do more than one part. So here's, right next to it is a 4.7K, which I happen to have right there. Didn't take me long to find it. I've seen people in billathons put the pile of parts out there, never pre-sort, and as they're building, they have to search through that whole pile again to find the right resistor. And they just keep searching the same set of parts over and over and over again. Now, I'm going to be a little anal about this because I noticed that the moniker, I can read right to left, so I'm going to leave them all the same way. So I probably should have did it the other way around, because you reading the part here, you want to read the colors the same way, but it doesn't make any difference. I mean, a good QRP person should be able to read the part left and forwards and backwards. So I'm going to do some more. So what's the next one? 220. So here's a 220 right here. I'll bend it to 0.4 inches. 220 was right down here. Now I'm not going to care about which way the color stripes go, so I'll just bend that off. Set it down. Oops, what's the next one? Next one is a 100 ohms. We got 100 ohms is the one that's already pre-bent. So we'll put that up here at the 100 ohms. Same thing, I'm going to put it in. I'm going to just use my fingernail and just spread them out a little bit. Next one is a 1K. Okay, that's pretty easy to find. And 1K was right down here at the bottom of this voltage divider that sets the base voltage of the final transistor. Next one up here is an 8.2K, which is right here, 8.2K. I'm looking at it, I'm verifying the colors before I solder it in. You notice I did not have a desoldering tool here because I don't plan on making any mistakes. So there's your 8.2K, and the last one is a 56. And 56, there's your green blue, 0.4 inches. Okay. And 0.56, not 0.56, 56. And voila. There they all are. There's all the resistors on the board. Now you notice I can conveniently just swing this all over the place. So I'm going to take my iron. I'm going to clean the tip, get it nice and clean. Add a little bit of solder, and then I will tackle them one at a time. One over here. Okay. Now I can tell the last part and this part here I just soldered on, the last leads. They have little ground rays that go to the ground plane, because that's a grounded lead on that part, and those ground rays take and move the heat off the iron to the whole ground plane. Now that piece of copper out there, so those take a little bit longer to heat up, and you just sort of have to watch it. So that's why you notice it took a little bit longer for that to heat up. So I'm going to let it set for a second. I'll just move in there and add a little bit of solder, and there you go. Go around to the back side. There it is. Now here's a couple more ground guys up here, and they're right on the outside edge of the board. So I'll get my iron in there. And again, I'm watching that solder flow off the iron, and I can see it form that fillet, and then I know it's done. Nice fillet, it's done. I go back over and do this guy. And you don't want to pile a lot of solder in there. You just want just enough to make a good connection. Now those last batch of them solder very quickly because they're part of the actual circuit path, and they don't have ground traces. I'm just I'm inspecting my solder job, and they all look pretty good, so I'll pop the board off and put my finger over it. And cut all these things off at the base. Cutting them right into my trash can. There they are. So, whoops, one didn't make it. So there are all the resistors soldered in. They're all nice, laying flat against the board. So now what we can do is we can go after some of the other flat pieces, and they would be the diode and the chokes, because they look just like resistors. So I'm going to cut that pin off and do the same thing. I can see that's that's set at 0.4. So on diodes, there's a little bar on the plus side of the diode, and I see the bar on the circuit right here. So I'll just put that in. I'm going to help it down from the back side by pulling on it. It's a little bit better than trying to push. Pulling leads a little bit better than pushing leads. Okay, so there we go. We got some chokes here. So what's this guy right here? This is a brown, black, black. And that's a 1 and a 0 with a 0, 0. So that is 10 microhenries. So I'm going to put down at 0.4. 10 microhenries. So I happen to know that is, it should be right here in the, where'd it go? It's supposed to be there somewhere. Oh, there it is, right there along the side. So I kept thinking I was going this way. I haven't built this board in a while. So see, I just violated my own rule about, finding something, then going to get in the parts. And now I had the part, and then I had to find it on the board. So it's easy to just sort of see something and say, okay, I'm going to put that down. Here's a 22 right here. So I'll go back to the right thing. So here's a 22, and there's a red, black. That's 22. So we'll cut that off. Bend it now. Now you can bend the leads with your fingers. You can bend them with a pair of pliers. But you know, with a nice lead former, they're not very expensive. 22 went right in here. So it just takes a little bit. It doesn't stress the part that much when you actually have something you're bending against. So now I know the only two left are these ones, and I know exactly where they go. They're in the filter, the low pass filter. I'll bend them first. Okay. And they go up there as a 1 and a 1. So I'll just put them up there. Put this one in. Okay. Put my 2 fingers on there. Bend the leads out a little bit so they don't fall out. And I can put this on my can. And I can solder all those leads. So here we go. We'll clean the iron. Add a little dollop of solder. Now these guys are a little spread out a little bit more than the resistors were, so we'll just let it heat a little bit, add a little solder, and away it goes. Again, adding just enough solder to give it a decent little connection, but not too much that you got a heck of a blob there. It also helps if you do make a mistake. The less solder that's on there, the easier it is to get the part off and get another part on. If you got a ton of solder there, it just doesn't help. And of course, solder bridging is a real problem. When you got too much solder, you'll end up putting solder onto the next pad. So, 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, they all look like they're soldered nicely. So I'll put my soldering iron away. Get my lead back again. Put my finger over the end. Go right down to the edge of the board, right to the surface. And okay, there are all the resistors, diode, chokes. Oops, another one just sort of didn't quite make it in the can. So now we can decide what's left else on this thing. Well, the next lowest thing on the board are these capacitors. So I'm going to start at one end.